So let's go ahead and do some examples on the topic of converting angles among the different forms that we've introduced so far. So for my first example, I'd like to convert 32.586 degrees to degrees, minutes, seconds form. Now please notice that we have an extra 3 decimal places on here, which is what I had mentioned in an earlier video. So ultimately for DMS form, what we're going to be looking for is a certain number of degrees, a certain number of minutes, and a certain number of seconds as the final form for our final answer. Each one of these numbers in here should be a whole number. So anytime we have a number that's not a whole number, we're going to split it into a whole number part as well as a decimal part. So first thing I'm going to do is say that we can interpret this as being 32 degrees plus 0.586 degrees. So I know that as part of my final answer, I'm going to see 32 degrees in there. Now, as far as how many minutes I have, what I'm going to do is take that decimal portion of degrees that I have. I'm going to convert it from degrees into minutes. The conversion that I mentioned earlier that we're going to be making use of is the fact that 1 degree is equal to 60 minutes. As a result, if I multiply by the units that I'm converting to divided by the units I'm converting from, this will give me a good calculation. So 60 degrees for every 60 minutes for every 1 degree. Now, not 100% sure what that is off the top of my head, but the good news is I have my handy dandy TI-84 Plus Color Edition. So we'll take that 0.586, we're going to multiply that by 60. The result that we get here is 35.16 minutes. Now with that in mind, what I'm going to do is do the same thing as what I did just a moment ago. I'm going to split this up into a whole number of minutes, 35 minutes, plus 0.16 minutes. So I know that as part of my final answer, there will be a total of 35 minutes. Then I'm going to take my decimal portion, which is this 0.16 minutes. I'm going to convert that from minutes into seconds. We're going to use a similar conversion. 1 minute is equal to 60 seconds. So multiply by a fraction that is the thing that I'm converting to divided by the thing that I'm converting from. That'll be 60 seconds per 1 minute. I'm pretty sure I got this without a calculator, but just to make sure, we'll take that 0.16, multiply by 60, and we got ourselves 9.6. Now, typically what we'll do when it comes to the number of seconds is we are going to round to the nearest second. So rounding this to the nearest second, I would refer to this as 10 seconds. So 32 degrees, 35 minutes, and 10 seconds would be the same as 32.586 degrees. Now if we want to go the other way, this involved a lot of multiplying by 60. The next example is going to involve a lot of dividing by 60. So we're going to convert 57 degrees, 39 minutes, and 15 seconds into degree decimal form. Now, this one is going to be relatively straightforward. What I'm going to do is take my 57 degrees, 39 minutes, and 15 seconds, and interpret it exactly like this. This would be 57 degrees plus 39 minutes plus 15 seconds. In order to convert from minutes back into degrees, I'm going to take my 39 minutes, and I'm going to multiply by 1 degree per 60 minutes. That's going to give me a total number of degrees after this. So that's the same conversion as what we were using back on the top part of the page. Multiply by the thing that we're converting to, divided by the thing we're converting from. Now the 15 seconds, this is going to be done in 2 steps. The first thing I'll need to do is convert my seconds back into minutes. So that'll be 1 minute per 60 seconds. That should be multiplication, excuse me. And then multiply by 1 degree per 60 minutes. What should happen is your units of seconds will cancel out, your units of minutes will cancel out, and you'll be left with degrees. Now really, if we wanted to abbreviate this process, what we're saying here is we're taking 39 over 60 degrees plus 15 over 60 squared degrees from the 2 times that we divided by 60. If you'd like to use this as a shortcut, which is divide minutes by 60, divide seconds by 60 squared, and you'll get to your answer that much further, you go ahead and feel free to do so. We'll bring in the calculator. We're doing 57 plus 39 over 60 plus 15 over 60 squared. Add it all up, or let the calculator do it for you. We get 57.654. If I'm going to round to the 3rd decimal place, I would cut it off at that 4. So we'll say this is approximately equal to 57.654 degrees. That's rounding at the 3rd decimal place. Now do read the directions carefully on any given problem. As far as rounding is concerned, it'll specify what it would like you to do. Now, for the second set of conversion problems, we're now going to talk about the other conversions that we had, which were degrees, radians, and revolutions. So first thing I'd like to do is convert 150 degrees into radians. Excuse me. The conversion that we had from another video is that 180 degrees is the same as pi radians. We're going to use the same principle as before. Multiply by the units that we're converting to, divide by the units we're converting from. So 150 degrees times, we're converting to radians, so radians goes on top, degrees goes on the bottom. Now we can interpret 150 as 150 over 1 and call this 150 pi over 180. This is a fraction that'll need to be reduced. Greatest common factor of the top and bottom would be 30. If I reduce each by 30, I will have 5 pi over 6. Or we could also express this as 5/6 pi. Now just to give a little visualization as to what this angle would look like, what I'm going to do is sketch this angle in its standard position. Great way to do this is to get into the habit of labeling your quadrantal angles. So as we're rotating around, I see that we're at 150 degrees. 150 would be between 90 degrees and 180 degrees, but 150 is definitely closer to 180 than it is to 90. So I am going to sketch this in such a fashion where it's closer to 180 than it is to 90, but still between them. Now if we wanted to do this in radians, of course, we could label it in terms of radians. This would be 0. If we do the appropriate conversion, this would be pi over 2, pi, 3 pi over 2, all the way up to 2 pi. The fraction that we had was 5 pi over 6. 5/6 is slightly less than 6/6, which would be 1 pi. So 5 pi over 6 is going to be in between pi over 2 and pi. And indeed, if we got a common denominator for all of them, this would be 3 pi over 6, 6 pi over 6, 5 pi over 6 would be in between them, but closer to the 6 pi over 6 than the 3 pi over 6. Now for the next example, we're going to do something similar, but we're going to go backwards. We're going to go from radians into degrees. You'll notice, though, that this angle is given as having a negative measure. We are converting to degrees. We are converting from radians. Now with this in mind, I like to try to simplify this as much as possible before we turn it into one big fraction. So we can take the pi and the pi and cancel those out, one on top, one on bottom. 4 will go evenly into 180, a total of 45 times. What you're left with is 7 times 45, and you are welcome to make use of the calculator should you care to. This is negative 315 degrees. Now, negative 315 degrees, what we're going to do for this one is label the quadrantal angles as though we're rotating in the clockwise or negative direction. So we'll start with 0 degrees. Down here would be negative 90 degrees, then negative 180 degrees, negative 270 degrees, and negative 360 degrees. The angle that we have is negative 315 degrees. Negative 315 would be exactly halfway between negative 270 and negative 360. So I'm going to try to draw it in such a way where it's exactly halfway in between those. Now if we wanted to do this in terms of radians, of course we could. This would be 0 radians, negative pi over 2 radians, negative pi radians, negative 3 pi over 2 radians, and negative 2 pi radians. If we get a common denominator for everything, in terms of a denominator of 4, this would be negative 6 pi over 4, and this would be negative 8 pi over 4. Negative 7 pi over 4 would be exactly halfway between negative 6 and negative 8. Finally, we're going to convert from revolutions into degrees and radians. This is 0.3 revolutions. So for radians, we will be multiplying by radians on the top, revolutions on the bottom. The conversion that we had earlier is that 1 revolution is the same as 2 pi radians. If I take these and put them together, this would be 0.6 pi radians. Or, if we wanted to express it in terms of a denominator, 0.6 is the same as saying 3/5. So 0.6 pi would be 3/5 pi, also known as 3 pi over 5. In order to convert to degrees, we need that 1 revolution is the same as 360 degrees. So convert to on the top, convert from on the bottom. 0.3 times 360 would be the same as 3 times 36. 3 times 36 would be 108 degrees. Using similar logic to what we did for our others, if I wanted to plot this curve, or plot this angle, 108 degrees is slightly bigger than 90 degrees, but not as big as 180. So I would draw this in such a way that it looks like it's slightly bigger than 90 degrees. You also notice that 0.3 revolutions would be slightly bigger than 1/4 of a revolution, which would be 0.25 revolutions. So hopefully these examples look good. Please feel free to rewatch and leave questions in the comments.